Welcome to today's webinar. It is a great pleasure to host Lauri and Juha talk about their book Biometry for Forestry and Environmental Data with examples in R. And before I give the floor to Lauri and Juha, I would like to first acknowledge that I'm hosting this webinar from my home in Port Coquitlam, British Columbia, which is located on the traditional, ancestral, and unceded territory of the Coquitlam First Nation. I thank the Coquitlam First Nation who continue to live on these lands and care for them along with the waters and all that is above and below. Second, I'd like to make you aware that the webinar is being recorded with the plan to make it available on the IUFRO webpage. And third, I would like to acknowledge that this webinar, and let me switch to the next page, that this webinar is part of the 2022 Forest Mensuration and Modelling Chats and is organized by IUFRO Research Group 401 Forest Mensuration and Modeling. And the plan is to have one webinar per month with the July-August summer break. And if you have, we're still looking for speakers. If you have speaker suggestions, please email me at bianca.eskelson@ubc.ca and give me suggestions. I would also like to highlight IUFRO's mission to advance research excellence and knowledge sharing and to foster development of science-based solutions to forest-related challenges for the benefit of forests and people worldwide. And in the spirit of knowledge sharing, I invited Juha and Lauri to talk about their book because I strongly believe that the development of science-based solutions is rooted deeply in the solid understanding of forest biometrics and modeling. And with that, I'll stop sharing my screen and hand it over to Juha and Lauri.
Okay, thank you. Thank you for your introduction, and I will now share my screen. Hopefully you can see it now. Okay, so thank you for the invitation. It is a great pleasure to start this series by this introduction of the book. We have been working with Juha for quite many years, and that was finished a couple of years ago. So the topic is our favorite parts of the book, previously unpublished material, new research ideas, and things learned during writing. And let's see if we can cover or meet your expectations related to that. So our outline is quite simple. Actually, mostly we are speaking about the other favorites, but we didn't put subheadings there. And before we go to the contents of the book, we first tell about ourselves. Of course, many of you know us, but probably not all of us. So we introduce ourselves. So I'm Lauri Mehtätalo. I was born in 1975, and my background is in forestry. So I did my master's and PhD in forestry, but I gradually moved from forestry to statistics. So at the same time, when I completed my PhD in forestry, I also completed master level studies in statistics. And then actually I started as a forest planning positions at university, but then I moved to forest statistics, and I finished at the university as a professor in applied statistics. But a little bit less than a year ago, I actually moved back to forestry, and I'm now working at the National Resource Institute Finland, which was formerly Metla. And maybe Juha can introduce himself. I think you can tell my story. Also. Okay. So Juha was born in 1951, and he has taken another direction. So he started as a mathematician and statistician, and then moved gradually to forestry. And I think he's the first forester and first person in Finland to use mixed effect models in his PhD in 1986. And I really appreciate that, because in those days you really had to program all the codes for the mixed effect models. So there were no R's or no other software for that. And he did his research career as a senior scientist at Finnish Forest Research Institute, Metla. So it is the ancestor of Luke. And in addition to statistics, he is known about about his knowledge about linear programming software and methods. And then the story behind the book. So actually, Juha was teaching forest biometrics at the University of Joensuu when I was student, and this shows a book of that course those times. So it is a Finnish, and the name is Models for Forest Biometrics, and it was a quite heavy stuff and not so many examples and no R scripts and no software. So that's why it was maybe one of the most demanding courses we had there. And then I took over the responsibility and started to teach that later, and then I included R examples and web page to the book, to the course.
I would like to say at this point that I was well known that I was a very bad teacher, but Lauri, there were some excellent students who understood even my teaching, and Lauri was one of those.
Yeah, I think that most of the students who got highest grades, they are professors or researchers, maybe. Yeah, but anyway, that was very good course and so on. And then based on the material we had, we promised in 1914 to submit a book to Taylor Francis, and we originally planned to have it ready already in late 1916, but then it took 4 years more, and we finally got it ready in 2020. Here you see the initial table of contents and part of our book proposal. You see that it's not exactly what we have in the book, but then this is what we have in the book. So I have here put it into actually four sections. This should be number 4 here. So just to show the overview and snapshot of the contents. So we think that the basics, statistics or forest biometrics cannot be understood if you don't understand well basics of probability, and therefore we included a chapter on random variables and statistical modeling, estimation and prediction. So they are the necessary theory understanding about statistics and background knowledge. And then maybe the main contents is here in the basics on linear models and linear mixed effect models. You see it's almost 200 pages, so it's more than 1/3 of the book. Linear model, linear mixed effect models, and then more about linear mixed effect models. So we couldn't fit the LMEs in the one chapter, so we had to split it into 2. And then we have extensions of linear model and linear mixed effect models, which includes nonlinear models, generalized linear, multivariate models, and then additional topics of regression. And actually we are looking quite much about the top contents of this chapter later today. And maybe I can note that in this chapter of linear model, we try to take a focus where we get rid of the normal OLS model, the model with homoscedastic residuals and independent errors. We try to get rid of that as early as possible and go to the generalizations where we have dependence and variance and so on in the models, because that is what we have usually in practice in spatial data and in group data sets and so on. And then we have some special forestry topics at the end of the book. And now we go to the favorite parts. So one of our favorite part is best linear unbiased predictor, and we are using that in very many parts of the book. So actually here we picked all the parts where we are discussing about that and showing how important formula it is. Usually, sometimes I have said that if you want to learn only one formula from statistics, then it's this formula, these formulas here. So if you have a random vector and its expected value and variance are given, and then they can be partitioned this way, and then the H2 has been observed, then the best linear predictor of H1 is given by these formulas. And this is best, and this is linear. This is best in terms of variance, and this is unbiased, but this unbiased here means that it's marginally unbiased. So over all observations, but it can be conditionally biased. Juha, do you want to say something more about this graph? Or?
No, I think that's sufficient.
Yeah.
But
Yeah.
it must be kept in my mind that there it's a difference between being marginally unbiased and conditionally unbiased. Yeah.
Yeah. So you see that here are the dots which indicate like the true data, and the marginal unbiasedness is, or this line here is marginally unbiased. So it means that on average the mean variability around this is, or mean difference to this line is 0, but not conditionally on any specific value of x. And then this bloop has a connection with the normal distribution, which is very well known, but maybe some people are familiar with those equations I presented as formulas of conditional expected value and conditional variance of the multivariate normal distribution. And yeah, they are, and they are the conditional mean and variance under normality. And in that case, actually, they are not only marginally unbiased, but they are the best predictors. They are the predictors with zero or with lowest variance. And this graph here shows that actually, when you have a multivariate normal, you have a linear relationship and constant variance around the line, which is indicated by these lines here. But we don't need to go to details. These are topics that are covered in the book. So if you want to look, just take a look in the book. And then I think Juha will talk about this slide.
Yeah, it is important to notice that in the standard regression context, prediction using best linear unbiased predictor and or a regression equation, they are basically equivalent. But in prediction, we can utilize if we have a model for a stochastic process. And in regression, the viewpoint is more static. And we can are working with models where we combine in prediction such kind of fixed effects regression model, then random effects, and for the residual part, the best linear unbiased predictor. And I've not seen this equation. It was from my dissertation where these three parts are presented in this way, but we can select in different applications. We have different combinations what we can have in the prediction. Okay, continue.
Yeah, and here is one example about the equation that was shown in the previous slide. So if you want to predict the random effects and residuals, then one special case of that is the geostatistical prediction. So in this book we have an example, and we present the geostatistical prediction, so the kriging as a special case of the GLS model. So we call the model where you have a non-constant variance or a dependence among the residuals. We call it GLS model, even though that is criticized by some of the reviewers of the book, but we still kept that naming. And this here shows an example where these plus signs here show observations, and the size of them shows the value of the response variable, and then these circles here show the prediction based on the fixed part of the model, and then if we calibrate or predict the residuals of the model, then we get those gray ones. So if you are close to the large observed value, then you get a value that is above the average, and otherwise some other parts you get smaller value. And here you see the variance. So actually here the area of the ball describes is proportional of the variance, and the radius is proportional to the standard deviation, because the variance is the second power of the standard deviation. So here you see that if you are close to the observations, then you are getting more accurate, bigger reduction to the variance. So this is a kriging example, but here we don't have random effects in this example. And then this is a very common application of this bloop, this random effect predictor in the linear mixed effect models. And I think our book is the first textbook where these widely used ideas, which actually originate from Juha's thesis and papers thereafter, where you predict the random effects for a new stand or new sample plot in the forestry context by using this bloop. So this is the first presentation of these ideas systematically in a textbook. But I also want to remind that unlike some people or some authors in papers say, this is not definitely the only reason to use linear mixed effect models in forestry. So always, if you have group data where you have where you should have random effects, then you should include them. And then the section 6.5 discussions prediction of jointly the random effects and residual errors in this context. So actually the formula that Juha already presented. And then the section 6.6 is actually something that is completely new. We have not seen that. So this is about applying the best linear unbiased predictor in a new group without re-estimating the model. So this is how it is used usually done in the forestry context. And what is new here is that Juha has derived the variance estimator for this particular case, which takes into account the fact that you use the estimates from the model fitting stage and then to calibrate them using the local measurements. And then we have also the random effect prediction using NLME. This is also very widely used in forestry literature. And now this is explained as well as we can in the context of nonlinear mixed effect models. And also we have a lot of R codes like shown here on the right, R script showing how we can implement this random effect prediction using the two alternatives that are used in the literature. So either Taylor expansions of the linear model at the predicted random effects or at the expected values of the random effects. Okay, and then we have also prediction using multivariate models. As you see here, there are formulas that looks quite intensive, let's say, and then some scripts about that. So we have formulas and scripts and everything for fitting the multivariate models and also for prediction of random effects. And in this case, actually, here we can see that. So here we can use the cross-model correlation to calibrate the random effects for some response that has not been measured by using a response variable that has been measured from the sample plot or from the tree. And here you see two alternatives. One way is to use Juha's formula where you first predict random effects and then the residual errors, but actually I personally like more this formula here, and we had some negotiations during the writing of the book that should we include this, and Juha said that you should drop this formula away, but I said that no, I want to keep it. So we don't agree on exactly everything we have in the book. So there are two alternative ways to do the same, and you get, of course, exactly the same result. And then here is the example about calibration of predicted diameter distribution. This is from my PhD thesis actually. So you can take sample quantiles of a sample plot. So smallest tree of the plot or biggest tree of the plot or median tree of the plot or any quantile. And then if you have a predictive model that gives this dashed line here as a diameter distribution, then you can utilize those measured quantiles to predict the distribution, and in this particular case you get this kind of bimodal distribution. So this is also application of the bloop. Okay, and this was the part about the best linear unbiased predictor. So there are a lot of applications of that in the book, throughout the book. And then one thing that we wanted to point out here is the collection of calculation rules. So whenever you want to work with variances and covariances and means, so first and second order properties of the distribution, then the formulas you have here, they are very useful and very important. And I think it's very nice to collect them all in the same place. And they are now here on the pages 23 to 25 of the book. So if you don't remember them by heart, you can check them from here. For example, here is the variance for the sum, is the sum over the covariance matrix, which is quite interesting rule actually. And then Juha will talk about this slide.
Yeah, it is that the problem is this question arises in the two situations when estimating a regression model using the transformation, and then we need to make a back transformation, or if we are estimating the mean of some nonlinear function, and we know the mean of the x variable, and we know the variance, and this method uses 2-point distribution, so that half of the weight is put mean plus standard deviation, and half of the weight to mean minus standard deviation. And this is very robust and good way to compute the mean of nonlinear function. And the other alternatives are, for instance, Taylor series, but Taylor series is not often very good for quite simple looking formulas. And in a 2-point correction, the function is correct and the distribution is approximate. In Taylor series, the function is wrong, but it is integrated correctly. And it is, if x has finite rates, then it is possible to get feasible rates using mathematical programming, and it is the topic for future research to generalize this to multivariate case, because it is not trivial to get positive definite correlation structure. And this is well known for a long time, but not in forestry and in many statistical papers.
Yeah, I want to point out that so we also are covering the other back transformation bias corrections, but this is definitely the most easy way to do that. So don't need to compute any derivatives for different functions, but the same for all functions. So yeah, I really recommend this to be used. Okay, and yeah, still continue.
Yeah, then there is the measurement error problem in regression, and we deal with the standard situation where measured x varies randomly around true x or vice versa. And this is and also the nonlinear case, and this is standard stuff. But in often the situation is that between these two cases, and I derived there some formulas, but this is something where with future research is needed, and this measurement error problem is quite interesting. And next slide, please. And one situation where we need to deal with the measurement errors is that the purpose is estimate distribution. And here is the case, for instance, that we want to estimate the distribution of seedling density. And from we measure seedling density from fixed area plots, and we get, in this case, the measurement errors cause that the measured distribution is wider than the true distribution. And for instance, in reforestation studies, it's very important to know what's the percentage of stands where there is not proper reforestation. And okay, next slide, And then the distributions are very important in forest planning, where for instance, and here is the nearest neighbor pictures that the first figure is the true distribution of Y, and the second is the when we use one nearest neighbor. And the fourth slide subfigure is the optimal with respect to root mean square error. And the last is regression obtained with regression. And it should be recognized that the optimal root mean square error and correct distribution are conflicting goals. And I think we suggest that research should be done in this area where we pay more attention to distributions. Next. And this is one question that we have discussed, the between group and within group effects. And in this figure, you see that the within group behavior is opposite to the between group behavior. And if we make ordinary least squares regression, we get the downward slope. But if we make the JLS estimation, then we get upward slowed. And we know that if somehow the assumptions of are correct in the model, the ordinary least squares should give unbiased estimates, even if there is some problems with the variance. And here in this equation, we are expressing that we have the mean between group effect X bar, and within group effect is described with this deviation from mean. And standard equation assumes that these have the same coefficient if we have just put X as a predictor. And that deviation from mean can describe the competition effect, which is linked to the negative correlation. And when it is very often useful to assume that the true group mean should be in the model, but when it is known, we have the measurement error bias problem, and here we suggest a solution using multivariate mixed effects model, which is new. And this question that the between group effect and within group effects work in different direction. It's related to the ecological fallacy or Simpson's paradox. Yeah, go. And then this deals with how the correlation question, how the correlation structure of residuals and regressor values interact. And surprisingly, I did not find any literature about this, and I started to work on this problem. And this is shortly presented. The initial results are presented in one box which discusses blue related to minimum root mean square error. And on the left figure, we see that the result is that small within group variation of residual errors is beneficial if there is large within group variation of the predictor variables. So this is related to the between group, within group effects discussed in earlier, but there is a paper coming, I hope next week. It will be published in Open Journal of Statistics about this question. And then this is the most simple mixed model. Y is equal mean plus random group effect plus random individual effect. But what is the mu? It is the expected value of Y when we pick group I randomly from the population of groups, and individual is picked randomly from the group I. And it is not generally equal to the expected value when an individual is picked randomly from the population of individuals. And I think this question should be given attention in, for instance, in forestry applications. And we analyze this question using weighted distributions, which appear also in other places in the book. Yeah. And then we success that the nonlinear mixed model, where there are random parameters, we could study the variation of curves using principal components of random parameters. This is related to my dissertation, where I had a multivariate mixed model where I used principal components for the between group effects. And the second question is that we often see in papers where there's a standard error is plotted with respect to a number of observations. And I have seen in many cases that people look at this picture and say, oh, it seems to saturate at around 5. But this is totally a visual artifact. It is dependent what is the range of n for which the plot is made. And this is just such kind of small notice there, okay? And then forest experiments, we did not know very much about this, but we wanted to include this in order to emphasize that we do not know much about forest experiments, and the methodology has been developed for agricultural experiments very much. But there are many things which make forest experiments different than agricultural. And the main question is that even if we make experiment according to statistical design and to make correct statistical analysis, but how can we generalize the results outside the study area for different years? There are so many such kind of nuisance factors. And okay, that's enough.
Yeah. And then we go to the chapter 11 and chapter 11.3. I think the mathematics of size distributions is something that is not written before. So examples include, for example, R-scripts for recovery of diameter distribution parameters and high diameter models in different contexts. And implementations utilize Newton's algorithm, step halving, and numerical integration routines. So in principle, this chapter tries to put or give everything that you need when computing using diameter distributions and all necessary mathematics for that. In addition, you need, of course, the information from the first chapters of the book. And then the last point we want to make that, of course, we have a lot of useful R scripts. I'm not trying to make them visible enough for you, but anyway, there are some parts. For example, we have scripts for some iterative algorithms for fitting linear models or nonlinear models. And then here are examples about the recovery of diameter distributions. So we have defining functions, and then we are using some Gauss-Newton method to solve that. And then here is some example about nonlinear models, and actually we have a lot of scripts where we need to extract some parameter estimates from the fitted model, and that is actually something that you cannot find in the manuals, that how they are extracted. And these scripts are actually something that even myself I need to look every now and then from the book when I need to do extract some variance covariance matrix or some correlation parameter from the model. Then we have the multivariate model fitting scripts, for example, using where the multivariate models are fitted using univariate linear model fitting routines. And finally, we are in the last slide. So not anymore about the favorites, but final words. So about the process. First, it was actually very easy to get the book proposal accepted. It took only 1 or couple of months to get acceptance, and the writing itself was surprisingly fun, even though of course the delay caused some stress, but the collaboration with Juha was very, very good, and we could utilize the strengths of both authors. For example, when I was writing the first version of the linear modeling chapter and give it to the comments to Juha, then I need to rewrite it. So Juha was a very good back or in the very well ensuring that the quality is high enough, and we had a very good collaboration in that. And of course, using LaTeX saved a lot from technical problems related to writing. And Juha wanted to say that he learned to use LaTeX during the process, but he didn't learn to use R during this. So all R scripts are from me. So Juha is using some other software for computation. Technical sharing of files, we worked with Google and email, and continuous support and trust from publisher was very good and useful. And even though we had the delays, they still always said, okay, you get more time. Okay, what else could they do? And of course, there are a lot of equations, and correlation between the number of equations and mistakes is of course positive. So there's always possibility for mistakes, even though we have been trying to be as careful as we can. And then also we had to update our knowledge, for example, in testing theory or REML estimation during the writing and after the reviews of the reviewers of the book. And then here is the last slide, and maybe if you think that you want to buy the book, I have asked from publisher a promo code for this event. So using this promo code, you can get 25% discount if you want to buy the book. But otherwise, we thank you for your interest, and we are ready for questions. I'm sorry, it took a little bit more than half an hour, but anyway, we have some time for discussion.
Thank you, Juha and Lauri. So for those of you who haven't read the book, I hope you got curious and know which sections to go to learn some more on different topics. And in terms of questions, we have about 10 to 15 minutes for questions. If you sort of hover over the bottom of your Zoom screen, you'll see some icons pop up. And on the far right, there should be a smiley face that says reactions under it. And if you click on that, you can use the raise hand function to raise your hand, and you can also post questions in the chat. And Celine just posted a comment in the chat. Thank you. This is going to be the most useful book I have seen in a long time. Your efforts are appreciated and will make all our research better, clearer, and easier. Again, thank you. And
okay, yeah. Thank you. Yeah.
Okay, any questions? Any raised hands? If there are no questions, I will start with one. Anybody?
Okay, I would like to make one comment about the errors in the formulas. I offer a cup of coffee for each error you find in the my equations. So I encourage you to try to get some free coffees.
And they are given in Suonejoki in.
Yes, yes.
Yeah.
In a small town in central Finland.
Yeah.
Okay, any questions? No, I have a question. So when I read the book, I really enjoyed the boxes and had to laugh sometimes because some of the boxes have things that I tell my students in classes. So I really enjoyed that. So Juha and Lauri, do you have any favorite boxes? So they sort of, I think, contain little bits of knowledge here and there. Do you have any favorite bits you'd like to talk about?
I would. I think I wrote the most of the boxes because Lauri did write the most part, the main part of it. But for instance, I like the Finnish second level parameters which I have been applying, and I think I was able to introduce some such kind of somewhere quite old things which I have learned a very long time ago, and I have not had possibility to somehow use that kind of knowledge. So it was very nice to work with the boxes.
Yeah, I could say that my favorite this box on page number 95, blue or minimum RMSE. The first part of that was translated directly from Juha's Finnish book, and there is this one sentence which says that the use of GLS instead of OLS make a difference between statistical modeling and curve fitter. So that's, I think, a very, very good sentence to learn and take home message. So if you want to get a low RMSE, you of course should use OLS, because OLS is a method to minimize RMSE. But if you want to get something better, you are using GLS. But necessarily, when you use GLS, your RMSEs are getting higher than if you used OLS. And that is actually something that is very poorly understood. For example, if people want to use fixed effect model instead of mixed effect model because the RMSE is lower for them.
And I think that's very important when people develop new methods which are not standard statistical methods. They use that root mean square error as a main criteria to compare models. Are root mean square error and bias. And they are very problematic, and people do not realize that they are very problematic in many cases.
Yeah, but actually related to that, I would like to add maybe some idea that maybe I have not told to Juha as well. So maybe he can shoot it down right after I have given. But if you want to minimize RMSE, but if you think about, for example, estimations tree volume. If you fit the models using GLS, you usually have the highest variance for biggest trees, but the biggest trees are most important for carbon and for standing trees. So somehow, actually, you should give more weight to the biggest trees, but the variance function is giving them less weight because they have higher variance. So if you somehow take into account both the variance and the importance for your modeling point of view, then you could get some mixture of where you take into account the importance and the variance, and you get some weights that are different. You get something that might be between GLS and OLS. But so that is something that should be studied, maybe. Yeah.
So you are proposing a mixture of mixed models.
Yeah. I don't know.
Mixing mixed models. Yeah, that's maybe.
Yeah.
Okay, so I'll read a few comments from the chat and then maybe I'll turn off the record. I have a few more comments on the IUFRO side of things and then I'll turn off the recording and maybe there'll be some questions off the recording. A comment from Claudio, a fantastic presentation and amazing and useful book. Congrats to the authors. Dihai wrote, I already bought this book, easy read and follow. And Shubornav writes, thanks for showing insights of this book. Thanks for the promo code. And then Claudio asks, how can I have the book? Is it available online? Maybe Kate, you could possibly find the webpage real quick and copy it into the chat. And I will share my screen real quick to follow up and give the dates for the next.
The book, somebody is asking, the book is available in Amazon, but if you order it from Routledge.com, then you can use this promo code, and you can buy it both electronically or paperback. Yeah.
Okay. Thank you, Lauri. Does everybody see my screen with the upcoming webinars? Did I share that properly? Do you see that? So there are 2 upcoming webinars on Wednesday, March 30th, also at 9:05 Pacific Standard Time. Christina Stouthammer will talk about resilient and resistant urban forests and her adventures in statistical modeling of forest structure and response to disturbance. And then in the April webinar, will be on the 27th of April, and Céline Boisvenu from Natural Resources Canada will talk about carbon modeling and some efforts there. And Kate also just posted the information about the upcoming webinars in the chats if you want to copy those over. And if you want to receive the announcements, I will send them out, this event registration links via the Division 4 mailing list, and you can subscribe to that mailing list using the link given here that has also been posted to the chat. And if I get my act together in time, the webinars will also be posted on the IUFRO calendar, and we're still looking for more speakers. If you have any suggestions, please email me at bianca.eskelson@uvc.ca. And with that, thank you for your attention. I'll see you at the next event.